Welcome back to part 2 of our comprehensive guide on the CCNA certification, presented by KnowledgeCatch. Let's continue with our exploration of key networking concepts, starting with WAN concepts. WAN concepts are crucial for understanding how to connect geographically dispersed networks. A WAN, or wide area network, connects networks that are spread across large distances. This is essential for businesses with multiple locations or remote branches. Several technologies are used to implement WANs, including MPLS, Frame Relay (PPP), and Metro Ethernet. MPLS, or Multiprotocol label switching, is a high-performance technique that directs data through the network based on short path labels rather than long network addresses. This improves speed and efficiency. Frame Relay is a packet switch technology that uses virtual circuits to connect multiple sites. It's cost-effective and scalable, but has largely been replaced by more modern technologies. PPP, or point-to-point protocol, provides a direct connection between two network nodes. It supports authentication, encryption, and compression. Metro Ethernet extends Ethernet technology to the metropolitan area network (MAN), providing high-speed connectivity over large geographic areas. Leased lines such as T1 and E1 circuits offer dedicated, point-to-point connections between sites. They provide consistent bandwidth but can be expensive. Circuit switching, used in technologies like ISDN, establishes a dedicated path for the duration of a communication session. This is reliable but less efficient than packet switching. Packet switching, used in technologies like Frame Relay and MPLS, allows data to be sent in packets over shared networks. This is more efficient and cost-effective. VPNs, or virtual private networks, provide secure connections over public networks. They use encryption and tunneling protocols to ensure data privacy and integrity. DSL, or digital subscriber line, provides high-speed internet access over telephone lines. It's widely available, but can be affected by distance from the provider's central office. Cable broadband uses the same infrastructure as cable TV to provide high-speed internet access. It offers higher speeds than DSL, but can be affected by network congestion. Satellite connectivity is used for remote areas where traditional wired connections are not feasible. It provides wide coverage but can have higher latency. Cellular networks, including 3G, 4G, and 5G, offer mobile broadband connectivity. They are essential for mobile devices and remote locations. Understanding WAN concepts is crucial for designing and managing wide area networks, making it a key topic for the CCNA exam. Point-to-point protocol (PPP) is a data link protocol used to establish direct connections between two network nodes. PPP provides several features that make it suitable for point-to-point connections, including authentication, encryption, and compression. The main components of PPP are the Link Control Protocol, LCP, and Network Control Protocols, NCPs. LCP is responsible for establishing, configuring, and testing the data link connection. NCPs are used to establish and configure different network layer protocols, such as IP. PPP supports two authentication methods: PAP, Password Authentication Protocol, and CHAP, Challenge Handshake Authentication Protocol. PAP is a simple authentication method that transmits passwords in clear text. It is less secure but easier to implement. CHAP provides more secure authentication by periodically verifying the identity of the remote node using a three-way handshake. This prevents replay attacks and ensures the integrity of the connection. Configuring PPP on routers involves setting up the appropriate interface, enabling PPP encapsulation, and configuring the desired authentication method. Multilink PPP, also known as MPPP, allows multiple physical links to be combined into a single logical link. This provides increased bandwidth and redundancy. LCP establishes the PPP connection and negotiates configuration options, such as maximum transmission unit, MTU, size, and authentication methods. It also performs link quality monitoring to ensure a reliable connection. NCP establishes and configures network layer protocols, such as IP. It negotiates parameters like IP address assignment and compression options. PPP encapsulates network layer packets in PPP frames, ensuring proper data transmission between nodes. PPP offers several benefits, including flexibility, security, and support for multiple protocols. It is widely used for point-to-point connections in various network environments. Troubleshooting PPP involves verifying the configuration, checking authentication settings, and ensuring that the LCP and NCP negotiations are successful. Understanding PPP is essential for managing point-to-point connections and is a key topic for the CCNA exam. Frame relay is a WAN technology that provides efficient and cost-effective packet switch data transmission. Frame relay uses virtual circuits to connect multiple sites. There are two types of virtual circuits: permanent virtual circuits, PVCs, and switched virtual circuits, SVCs. PVCs are pre-established connections that remain active even when no data is being transmitted. They provide consistent and reliable connectivity. SVCs are temporary connections established on demand. They are set up and torn down as needed, making them more flexible but potentially less reliable. Data link connection identifiers, DLCIs, are used to identify virtual circuits in a frame relay network. DLCIs are assigned by the service provider and are unique within a frame relay network. The Local Management Interface, LMI, is a signaling standard used in frame relay networks. It provides status updates and management information between the network devices and the service provider. Frame relay encapsulation involves wrapping data packets in a frame relay header and trailer, allowing them to be transmitted over the network. This process ensures proper data delivery and error detection. Configuring frame relay on routers involves setting up the appropriate interface, defining the DLCIs, and configuring the LMI type. Frame relay offers several benefits, including cost-effectiveness, scalability, and efficient bandwidth utilization. It is suitable for connecting multiple remote sites to a central hub. However, frame relay also has drawbacks. It can experience congestion during peak traffic periods, and its performance may vary based on the quality of the service provider's network. Quality of service QoS in frame relay involves traffic shaping and prioritization to ensure that critical applications receive the necessary bandwidth. This helps maintain network performance during periods of high traffic. Troubleshooting frame relay involves verifying the configuration, checking the status of virtual circuits, and ensuring proper LMI communication. Understanding frame relay is essential for managing packet switch networks and is a key topic for the CCNA exam. Multiprotocol label switching, MPLS, is a high-performance WAN technology that uses labels to direct data packets through the network. MPLS uses short path labels instead of long network addresses to determine the route for data packets. This improves the speed and efficiency of data transmission. Label Distribution Protocol, LDP, is used in MPLS networks to distribute labels between routers. LDP establishes label switched paths, LSPs, for data packet forwarding. A forwarding equivalence class, FEC, is a group of data packets that are forwarded along the same path through the MPLS network. FECs are used to simplify and optimize routing decisions. MPLS configuration involves setting up label switching on routers, defining LSPs, and configuring LDP. MPLS offers several benefits, including increased speed, flexibility, and support for quality of service QoS. It is suitable for a wide range of applications, including voice, video, and data traffic. MPLS-based VPN services provide secure and scalable connectivity for remote sites. MPLS VPNs use label switching to isolate traffic between different VPNs, ensuring data privacy and security. Traffic engineering TE in MPLS involves optimizing the use of network resources by directing traffic along specific paths. TE helps improve network performance and manage congestion. Label switched paths, LSPs, are established in the MPLS network to direct traffic from the source to the destination. LSPs provide the foundation for efficient and flexible data forwarding. Troubleshooting MPLS involves verifying label distribution, checking LSP configurations, and ensuring proper LDP communication. Understanding MPLS is essential for managing high-performance WANs and is a key topic for the CCNA exam. A virtual private network, VPN, is a technology that provides secure connections over public networks, allowing remote users and sites to connect to a private network. There are two main types of VPNs: site-to-site VPNs and remote access VPNs. Site-to-site VPNs connect entire networks to each other, such as branch offices to a central office. This type of VPN uses routers or dedicated VPN devices to establish a secure tunnel between sites. Remote access VPNs allow individual users to connect to a private network from remote locations. This type of VPN typically uses software clients on the user's device to establish the secure connection. VPNs use various protocols to ensure secure communication, including IPsec and SSL/TLS. IPsec, or Internet Protocol Security, is a suite of protocols that provides encryption, authentication, and integrity for IP packets. It is commonly used for site-to-site VPNs and supports multiple encryption algorithms. SSL/TLS, or Secure Sockets Layer/Transport Layer Security, provides encryption and secure communication for web-based applications. It is commonly used for remote access VPNs. Tunneling is a technique used in VPNs to encapsulate private data packets within public packets, allowing them to be transmitted securely over public networks. This process hides the private data and ensures its confidentiality. Encryption in VPNs ensures that data transmitted over the public network is unreadable by unauthorized parties. It provides data privacy and protection against eavesdropping. Authentication verifies the identity of users and devices, ensuring that only authorized entities can access the VPN. This prevents unauthorized access and enhances security. Configuring VPNs involves setting up the appropriate protocols, defining encryption and authentication methods, and establishing the secure tunnel. VPNs offer several benefits, including secure remote access, cost savings by using public networks, and improved data privacy. However, VPNs can also have drawbacks, such as potential performance impact due to encryption overhead and the complexity of configuration and management. Troubleshooting VPNs involves verifying the configuration, checking encryption and authentication settings, and ensuring that the secure tunnel is established correctly. Understanding VPNs is essential for providing secure connectivity in networks and is a key topic for the CCNA exam. Security fundamentals are crucial for protecting networks from threats and ensuring the integrity and confidentiality of data. Network security involves protecting network infrastructure, devices, and data from unauthorized access, attacks, and vulnerabilities. Common threats to network security include malware, phishing, and denial of service (DoS) attacks. Malware, such as viruses, worms, and Trojans, can infect network devices and cause damage or steal sensitive information. Phishing attacks use deceptive emails or websites to trick users into revealing personal information, such as passwords or credit card numbers. DoS attacks overwhelm network resources, making them unavailable to legitimate users. This can disrupt business operations and cause significant damage. Vulnerabilities are weaknesses in the network that can be exploited by attackers. These can include unpatched software, weak passwords, and misconfigured devices. Risk management involves identifying, assessing, and mitigating risks to the network. This process helps prioritize security efforts and allocate resources effectively. Firewalls are security devices that control incoming and outgoing traffic based on predetermined security rules. They can be hardware-based, software-based, or a combination of both. Intrusion detection systems, IDS, and intrusion prevention systems, IPS, monitor network traffic for suspicious activity. IDS alerts administrators to potential threats, while IPS can take action to block or mitigate them. Encryption secures data transmission by converting it into an unreadable format. This ensures data privacy and protection against eavesdropping. Authentication verifies the identity of users and devices, ensuring that only authorized entities can access network resources. This can include passwords, biometrics, and multi-factor authentication. Authorization grants access to resources based on the user's identity and permissions. This ensures that users can only access the resources they are allowed to. Best practices for network security include regular updates and patches, strong password policies, network segmentation, and employee training on security awareness. Understanding security fundamentals is essential for protecting networks and data, making it a key topic for the CCNA exam. Firewalls are critical security devices that control traffic between different parts of a network based on predefined security rules. There are several types of firewalls, including hardware firewalls, software firewalls, and hybrid firewalls. Hardware firewalls are dedicated devices that provide network security. They are placed at the network perimeter and are capable of handling large volumes of traffic. Software firewalls are applications installed on individual devices. They protect the host by controlling inbound and outbound traffic based on security policies. Hybrid firewalls combine the features of hardware and software firewalls, providing flexible and comprehensive security. Packet filtering firewalls control traffic based on the source and destination IP addresses, protocols, and port numbers. They operate at the network layer and are the simplest type of firewall. Stateful inspection firewalls monitor the state of active connections and make decisions based on the context of the traffic. They operate at both the network and transport layers. Proxy servers act as intermediaries between clients and servers. They can filter traffic, cache content, and provide anonymity for users. Next-generation firewalls, NGFWs, offer advanced features, such as application awareness, intrusion prevention, and deep packet inspection. They provide comprehensive security for modern network environments. Network segmentation using firewalls involves dividing the network into smaller segments, each with its own security policies. This limits the spread of threats and improves security management. Firewall rules determine what traffic is allowed or denied. They are based on criteria such as IP addresses, protocols, and port numbers. Rules are evaluated in order from top to bottom. Logging and monitoring are essential for tracking firewall activities. Logs provide valuable information about network traffic and potential security incidents. Regular management and updates are crucial for maintaining firewall effectiveness. This includes reviewing and updating rules, applying patches, and monitoring for unusual activity. Understanding firewalls and their functions is essential for network security and is a key topic for the CCNA exam. VPN security is essential for ensuring secure communication over public networks. VPNs use various protocols to establish secure tunnels between remote users or sites and a private network. The most common protocols are IPsec and SSL/TLS. IPsec, or Internet Protocol Security, provides a suite of protocols for secure communication. It includes encryption, authentication, and integrity checking to protect data. SSL VPN, or Secure Sockets Layer VPN, uses SSL/TLS protocols to establish secure connections for web-based applications. It is commonly used for remote access VPNs. Encryption ensures data privacy by converting it into an unreadable format. Only authorized users with the correct decryption key can access the data. Tunneling encapsulates private data packets within public packets, allowing them to be transmitted securely over public networks. This process hides the private data and ensures its confidentiality. Authentication verifies the identity of users and devices, ensuring that only authorized entities can access the VPN. This can include passwords, digital certificates, and multi-factor authentication. Authorization controls access to network resources based on the user's identity and permissions. This ensures that users can only access the resources they are allowed to. Configuring VPNs involves setting up the appropriate protocols, defining encryption and authentication methods, and establishing the secure tunnel. Benefits of VPN security include secure remote access, data privacy, and protection against eavesdropping and unauthorized access. Troubleshooting VPN issues involves verifying the configuration, checking encryption and authentication settings, and ensuring that the secure tunnel is established correctly. Understanding VPN security is essential for providing secure connectivity in networks and is a key topic for the CCNA exam. Wireless security is crucial for protecting wireless networks from unauthorized access and threats. There are several security standards for wireless networks, including WPA, WPA2, and WPA3. WPA, or Wi-Fi Protected Access, provides enhanced security compared to the older WEP standard. It uses TKIP, Temporal Key Integrity Protocol, for encryption. WPA2 improves upon WPA by using AES, Advanced Encryption Standard, for stronger encryption. It is widely used in modern wireless networks. WPA3 offers even stronger security features, including SAE, Simultaneous Authentication of Equals, for better protection against password attacks and improved encryption. Encryption secures wireless communication by converting data into an unreadable format. This ensures data privacy and protection against eavesdropping. Authentication verifies the identity of users and devices, ensuring that only authorized entities can access the wireless network. This can include passwords, digital certificates, and enterprise authentication methods like 802.1x. The SSID, or Service Set Identifier, is the name of the wireless network. Broadcasting the SSID makes the network visible to devices, while hiding the SSID can provide an additional layer of security. MAC filtering allows network administrators to specify which devices can connect to the wireless network based on their MAC addresses. This helps control access to the network. Rogue AP detection involves identifying and mitigating unauthorized access points that may pose security risks. This can be done using wireless intrusion detection systems, WIDS. Guest networks provide isolated access for visitors, ensuring that they do not have access to the main network. This helps protect sensitive data and resources. Best practices for wireless security include using strong encryption, regularly updating passwords, enabling authentication, and monitoring for unusual activity. Understanding wireless security is essential for protecting wireless networks and is a key topic for the CCNA exam. Authentication, Authorization and Accounting AAA is a framework used for network security management. Authentication verifies the identity of users and devices, ensuring that only authorized entities can access the network. This can include passwords, digital certificates, and multi-factor authentication. Authorization grants access to network resources based on the user's identity and permissions. This ensures that users can only access the resources they are allowed to. Accounting tracks user activities and resource usage. This provides valuable information for network management, auditing, and billing. AAA protocols include Radius and TCAX+. Radius, or Remote Authentication Dial-in User Service, provides centralized authentication, authorization, and accounting for network access. It is widely used for managing remote access and wireless networks. TCAX+, or Terminal Access Control System Plus, provides similar functions but with greater granularity and security. It separates authentication, authorization, and accounting functions, offering more detailed control. Implementing AAA involves setting up a centralized server, configuring network devices to use AAA, and defining policies for authentication, authorization, and accounting. Benefits of AAA include enhanced security, centralized management, and detailed tracking of user activities. Troubleshooting AAA involves verifying the configuration, checking the communication between network devices and the AAA server, and ensuring that policies are correctly applied. Understanding AAA is essential for network security management and is a key topic for the CCNA exam. Network management involves monitoring and maintaining the health and performance of the network. Several tools are used for network management, including SNMP, NetFlow, and Syslog. SNMP, or Simple Network Management Protocol, allows network administrators to monitor and manage network devices remotely. It provides valuable information about device status, performance, and configuration. NetFlow is a network protocol developed by Cisco for collecting IP traffic information. It helps analyze traffic patterns, monitor bandwidth usage, and detect anomalies. Syslog is a standard for logging system events. It allows network devices to send log messages to a centralized server, providing a comprehensive view of network activities. Monitoring involves real-time observation of network performance metrics, such as bandwidth, latency, and uptime. This helps detect issues early and ensures optimal network performance. Performance metrics provide valuable information about the network's health and efficiency. Analyzing these metrics helps identify areas for improvement and optimize network performance. Configuration management involves tracking and managing changes to network device configurations. This helps ensure consistency, prevent misconfigurations, and simplify troubleshooting. Fault management involves detecting, diagnosing, and resolving network issues. This helps maintain network reliability and minimize downtime. Reporting involves generating regular performance reports to provide insights into network operations. These reports help track progress, identify trends, and make informed decisions. Alerting provides notifications for network issues, such as device failures or performance degradation. This helps network administrators respond quickly to potential problems. Automation involves using scripts and tools to perform routine tasks, such as configuration updates and backups. This improves efficiency and reduces the risk of human error. Best practices for network management include regular audits, timely updates, and continuous monitoring. Understanding network management is essential for maintaining network health and performance, making it a key topic for the CCNA exam. Syslog is a protocol used for logging system events and messages from network devices. Syslog provides a standardized way to collect and store log messages, making it easier to monitor and manage network activities. Severity levels in Syslog range from 0 emergency to 7 debug. These levels indicate the importance and urgency of the log messages, helping administrators prioritize issues. Facility codes indicate the source of the log message, such as the operating system, application, or network device. This helps categorize and filter log messages for analysis. Syslog configuration involves setting up network devices to send log messages to a centralized Syslog server. This centralization provides a comprehensive view of network activities and simplifies log management. Centralized logging allows for the collection and storage of log messages in one place. This makes it easier to analyze trends, detect issues, and generate reports. Log analysis involves reviewing log messages to identify patterns, detect anomalies, and troubleshoot issues. This helps maintain network security and performance. Retention policies determine how long log messages are stored. These policies help manage storage space and ensure that important log messages are available for analysis. Security is crucial for protecting log data from unauthorized access and tampering. This includes encrypting log messages, securing the Syslog server, and implementing access controls. Troubleshooting Syslog involves verifying the configuration, checking the communication between devices and the Syslog server, and analyzing log messages for potential issues. Best practices for Syslog include regular review and backups of log messages, setting appropriate retention policies, and ensuring log message security. Understanding Syslog is essential for effective network monitoring and management, making it a key topic for the CCNA exam. Cisco Discovery Protocol (CDP) is a proprietary protocol used by Cisco devices to discover and share information about directly connected devices. CDP operates at the data link layer, Layer 2, and allows network devices to exchange information, such as device ID, IP address, port ID, and capabilities. The primary function of CDP is to help network administrators identify and manage Cisco devices in a network. This information is useful for network mapping, troubleshooting, and configuration. CDP can be enabled or disabled on individual interfaces or globally on a device. By default, CDP is enabled on most Cisco devices. Security considerations for CDP include the potential exposure of network information to unauthorized users. To mitigate this risk, CDP can be disabled on interfaces that connect to untrusted networks or devices. Troubleshooting with CDP involves using the information provided by CDP to identify and resolve network issues. This includes checking device connectivity, verifying configurations, and identifying misconfigured devices. CDP version 2 offers improvements over the original version, including enhanced reporting capabilities and support for additional device information. Alternatives to CDP include the Link Layer Discovery Protocol, LLDP, an open standard protocol that provides similar functionality. LLDP is supported by a wide range of network devices, including non-Cisco equipment. Best practices for CDP include regular monitoring and configuration, ensuring that CDP is enabled only on necessary interfaces, and implementing security measures to protect network information. Understanding CDP is essential for managing and troubleshooting Cisco networks, making it a key topic for the CCNA exam. Network automation involves using tools and scripts to automate repetitive network tasks, improving efficiency and consistency. Benefits of network automation include reduced manual errors, faster deployment of configurations, and improved network performance and reliability. Common tools for network automation include Ansible, Puppet, and Chef. These tools use scripts and playbooks to automate network configurations and management tasks. Scripting languages such as Python and Bash are widely used for network automation. They allow network administrators to create custom scripts for specific tasks and workflows. APIs, or application programming interfaces, provide a standardized way for software applications to interact with network devices. RESTful APIs are commonly used for network management and automation. Configuration management involves using automation tools to manage and update network device configurations. This ensures consistency and simplifies the process of deploying changes across the network. Monitoring and automated alerts help detect and respond to network issues quickly. Automation tools can be configured to send notifications or take predefined actions when specific conditions are met. Security is an important consideration in network automation. Ensuring secure automation scripts, using encryption, and implementing access controls help protect the network from unauthorized changes. Deployment automation involves using scripts and tools to deploy configurations and updates to network devices. This speeds up the deployment process and reduces the risk of errors. Best practices for network automation include regular testing, version control for scripts and configurations, and continuous monitoring of automated processes. Understanding network automation is essential for modern network management and is a key topic for the CCNA exam. Cloud services provide a wide range of computing resources over the Internet, offering scalability, flexibility, and cost efficiency. There are three main types of cloud services: Infrastructure as a Service, IaaS, Platform as a Service, PaaS, and Software as a Service, SaaS. IaaS provides virtualized computing resources over the Internet, such as virtual machines, storage, and networking. This allows businesses to scale their infrastructure without the need for physical hardware. PaaS offers a platform for developing, testing, and deploying applications. It provides the necessary tools and frameworks, allowing developers to focus on coding without managing the underlying infrastructure. SaaS delivers software applications over the Internet on a subscription basis. Users can access the software through a web browser, eliminating the need for installation and maintenance. Popular cloud service providers include Amazon Web Services, AWS, Microsoft Azure, and Google Cloud Platform, GCP. These providers offer a wide range of services to meet various business needs. Benefits of cloud services include scalability, cost efficiency, and flexibility. Businesses can quickly scale their resources up or down based on demand, pay only for what they use, and access services from anywhere with an internet connection. Hybrid cloud combines private and public clouds, providing a balance of control and flexibility. This allows businesses to keep sensitive data on premises while leveraging the scalability of the public cloud. Security is a critical consideration when using cloud services. Implementing strong access controls, encryption, and regular security audits helps protect data in the cloud. Migrating to the cloud involves moving applications, data, and workloads from on-premises infrastructure to cloud environments. This requires careful planning and execution to ensure a smooth transition. Cloud resource management tools help monitor and optimize the usage of cloud services, ensuring cost efficiency and performance. Network integration is essential for connecting on-premises and cloud environments. This involves configuring VPNs, direct connections, and other methods to ensure seamless connectivity. Best practices for using cloud services include regular audits, cost management, and staying updated with the latest security practices. Understanding cloud services is essential for modern network management and is a key topic for the CCNA exam. IPv6 is the latest version of the Internet Protocol, designed to replace IPv4 and address the limitations of the older protocol. IPv6 uses 128-bit addressing, providing a vastly larger address space compared to IPv4's 32-bit addresses. This accommodates the growing number of Internet-connected devices. The address format in IPv6 is written in hexadecimal notation, separated by colons. An example of an IPv6 address is 2001:0db8:85A3:0000:0000:8A2E 0370:7334. There are three main types of IPv6 addresses: unicast, multicast, and anycast. Unicast addresses identify a single interface on a network. They are used for one-to-one communication. Multicast addresses identify a group of interfaces, allowing one-to-many communication. Packets sent to a multicast address are delivered to all interfaces in the group. Anycast addresses identify a group of interfaces, but packets are delivered to the nearest interface in the group, providing one-to-nearest communication. IPv6 addresses have different scopes, such as link local and global. Link local addresses are used for communication within a single network segment, while global addresses are routable on the Internet. IPv6 supports both stateless, SLAAC, and stateful, DHCPv6, auto-configuration methods. SLAAC allows devices to generate their own IP addresses, while DHCPv6 provides centralized IP address management. IPv6 headers are simplified compared to IPv4, reducing the processing burden on routers and improving performance. Address representation in IPv6 allows for abbreviation rules to simplify the notation, such as omitting leading zeros and using double colons to represent consecutive zeros. Compatibility between IPv4 and IPv6 can be achieved through dual-stack configurations and tunneling mechanisms, allowing both protocols to coexist. Understanding IPv6 is essential for modern network management and future-proofing network infrastructure, making it a key topic for the CCNA exam. There are several types of IPv6 addresses, each serving different purposes in network communication. Global unicast addresses are globally routable and unique on the Internet. They are equivalent to public IPv4 addresses and are used for one-to-one communication. Link local addresses are used for communication within a single network segment. They are automatically configured on all IPv6-enabled interfaces and start with the prefix FA80:10. Unique local addresses are similar to private IPv4 addresses. They are used for local communication within a site and are not routable on the Internet. They start with the prefix FD00:8. Multicast addresses identify a group of interfaces, allowing one-to-many communication. They start with the prefix FF00:8 and are used for various network functions, such as routing updates and service discovery. Anycast addresses identify a group of interfaces, but packets are delivered to the nearest interface in the group. Anycast addresses are used for load balancing and redundancy. Special addresses include the loopback address 1, which is used for testing and local communication within a device, and the unspecified address, smiley face, which represents an unknown or unspecified address. Prefix length in IPv6 is similar to the subnet mask in IPv4. It indicates the number of bits used for the network portion of the address. For example, a /64 prefix length means that the first 64 bits are used for the network, and the remaining 64 bits are used for the host. Configuration of IPv6 addresses can be done manually, through DHCPv6, or using stateless address auto-configuration, SLAAC. SLAAC allows devices to generate their own addresses based on the network prefix advertised by routers. Scope ID is required for link local addresses to specify the network interface used for communication. This ensures that packets are delivered to the correct interface in multi-interface devices. Understanding the different types of IPv6 addresses and their applications is essential for effective network management and is a key topic for the CCNA exam. IPv6 configuration involves assigning IPv6 addresses to network interfaces and ensuring proper communication within the network. Static addressing allows for manual IP configuration. Administrators assign IPv6 addresses, prefixes, and gateways to devices. This method is suitable for devices requiring consistent addresses, such as servers. Stateless auto-configuration (SLAAC) allows devices to generate their own IPv6 addresses based on the network prefix advertised by routers. This method simplifies address assignment and requires minimal administrative effort. DHCPv6, or Dynamic Host Configuration Protocol for IPv6, provides centralized IP address management. DHCPv6 servers assign IPv6 addresses, prefixes, and other configuration parameters to clients. Router advertisements (RA) are messages sent by routers to advertise the network prefix and other configuration options. Devices use these advertisements to configure their IPv6 addresses. Neighbor discovery (ND) replaces ARP in IPv6 networks. ND is used to discover other devices on the same network, determine link layer addresses, and maintain reachability information. RA messages contain information about the network prefix, default gateway, and other configuration options. Devices use this information to configure their IPv6 addresses and routing information. The default gateway in IPv6 is configured using RA messages. Devices automatically learn the gateway address and use it for communication with other networks. DNS configuration in IPv6 can be done using RA or DHCPv6. Devices can learn DNS server addresses through RA messages or request them from a DHCPv6 server. Interface IDs in IPv6 can be generated using the UI64 format, which incorporates the device's MAC address. This ensures unique and consistent interface IDs. Verification of IPv6 configuration involves testing connectivity and ensuring that devices can communicate correctly. This includes using tools like ping, traceroute, and checking the routing table. Understanding IPv6 configuration is essential for managing modern networks and ensuring seamless communication, making it a key topic for the CCNA exam. Transition mechanisms are essential for enabling communication between IPv4 and IPv6 networks during the transition period. Dual stack is a transition mechanism that allows devices to run both IPv4 and IPv6 simultaneously. This enables communication with both IPv4 and IPv6 networks without the need for translation. Tunneling encapsulates IPv6 packets within IPv4 packets, allowing them to be transmitted over IPv4 infrastructure. This method helps connect isolated IPv6 networks across an IPv4 backbone. 6-to-4 is an automatic tunneling mechanism that allows IPv6 packets to be transmitted over IPv4 networks without requiring explicit tunnel setup. It uses the IPv4 address as part of the IPv6 address. Teredo is another tunneling mechanism that enables IPv6 connectivity over IPv4 NAT, Network Address Translation, networks. It encapsulates IPv6 packets within UDP packets, allowing them to traverse NAT devices. ISATAP, or Intrasite Automatic Tunnel Addressing Protocol, is used for IPv6 communication within an IPv4 network. It uses IPv4 as a virtual link layer for IPv6, simplifying the transition. NAT64/DNS64 is a translation mechanism that allows IPv6-only clients to communicate with IPv4 servers. NAT64 translates IPv6 packets to IPv4, while DNS64 synthesizes Quad A records from A records. Manual tunnels can be configured for specific links, providing a static and controlled way to connect IPv6 networks over IPv4 infrastructure. This method requires manual setup and maintenance. GRE tunnels, or generic routing encapsulation, can also be used to encapsulate IPv6 packets within IPv4 packets. GRE tunnels provide flexibility and support for various protocols. Performance considerations for transition mechanisms include potential latency and speed impact due to encapsulation and translation processes. Proper planning and testing are essential to minimize performance issues. Security is crucial during the transition period. Ensuring secure transitions involves implementing encryption, access controls, and monitoring to protect against potential vulnerabilities. Understanding transition mechanisms is essential for enabling seamless communication between IPv4 and IPv6 networks, and is a key topic for the CCNA exam. IPv6 routing protocols are essential for directing traffic within IPv6 networks. OSPF v3, or Open Shortest Path First version 3, is an extension of OSPF for IPv6. It uses the Dijkstra algorithm to calculate the shortest path and supports IPv6 address formats and extensions. IGRP for IPv6, or Enhanced Interior Gateway Routing Protocol, is a distance vector protocol that supports IPv6. It uses a composite metric based on bandwidth, delay, load, and reliability for route selection. RIPNG, or RIP Next Generation, is an extension of the RIP protocol for IPv6. It uses hop count as its metric and has a maximum limit of 15 hops. RIPNG is simple to configure but less efficient for large networks. BGP, or Border Gateway Protocol, supports IPv6 with extensions. BGP is a path vector protocol used for routing between autonomous systems on the Internet. It uses attributes like AS-path, next hop, and local preference for route selection. Route redistribution allows different routing protocols to share routes. This is useful in networks where multiple routing protocols are used. Redistribution requires careful planning to avoid routing loops and inconsistencies. IPv6 routing tables are separate from IPv4 routing tables. Devices maintain distinct routing tables for each protocol, ensuring proper routing of IPv6 and IPv4 traffic. Neighbor discovery in IPv6 replaces ARP, and is used for discovering other devices on the same network, determining link layer addresses, and maintaining reachability information. Prefix advertisement in IPv6 is done through router advertisements, RA. Routers advertise network prefixes and other configuration options, allowing devices to configure their addresses automatically. Configuring IPv6 routing protocols involves setting up the appropriate protocols on routers, defining network interfaces, and ensuring proper communication between devices. Verification of IPv6 routing involves checking routing tables, ensuring correct route advertisements, and testing connectivity between devices. Understanding IPv6 routing protocols is essential for managing modern networks and ensuring efficient traffic routing, making it a key topic for the CCNA exam. Practice questions are an essential part of exam preparation, helping you test your knowledge and identify areas for improvement. Question 1. Describe the function of the OSPF protocol. Answer. OSPF, or Open Shortest Path First, is a link state routing protocol used for finding the best path between the source and destination within an IP network. It uses the Dijkstra algorithm to calculate the shortest path and supports hierarchical network design with areas to optimize routing and reduce overhead. Question 2. How does DHCP operate in a network? Answer. DHCP, or Dynamic Host Configuration Protocol, automatically assigns IP addresses and other network configuration parameters to devices on a network. The process involves 4 steps: discover, offer, request, and acknowledge, DORA. This simplifies network management and reduces the risk of IP address conflicts. Question 3. Explain the difference between a hub and a switch. Answer. A hub is a basic networking device that broadcasts data to all connected devices, leading to potential collisions. A switch, on the other hand, forwards data only to the intended recipient based on MAC addresses, reducing collisions and improving network efficiency. Question 4. What are the key features of IPv6? Answer. IPv6 offers a 128-bit addressing system, providing a vastly larger address space compared to IPv4. It includes simplified headers, improved routing efficiency, built-in security features like IPsec, and support for auto-configuration and multicast communication. Question 5. Describe how NAT improves network security. Answer. NAT, or Network Address Translation, hides internal IP addresses by translating them to a single public IP address for external communication. This obscures the internal network structure from outside observers, enhancing security by making it harder for attackers to target internal devices. Question 6. How do you configure a VLAN on a Cisco switch? Answer: to configure a VLAN on a Cisco switch, use the following steps. Enter Global Configuration Mode. Create the VLAN using the VLAN command. Assign a name to the VLAN. Assign switch ports to the VLAN using the switchport access VLAN command. Question 7. What is the purpose of ACLs in network security? Answer: ACLs, or access control lists, are used to filter traffic and enforce security policies based on criteria such as source and destination IP addresses, protocols, and port numbers. They control which traffic is allowed or denied, protecting the network from unauthorized access. Question 8. How does STP prevent network loops? Answer: STP, or Spanning Tree Protocol, prevents network loops by creating a loop-free logical topology. It selects a root bridge and uses BPDUs, Bridge Protocol Data Units, to determine the best path to the root. Redundant paths are placed in a blocking state to prevent loops. Question 9. Explain the difference between TCP and UDP. Answer: TCP, Transmission Control Protocol, is a connection-oriented protocol that ensures reliable data delivery with error checking and flow control. UDP, User Datagram Protocol, is a connectionless protocol that offers faster data transmission without guarantees of delivery or error checking. Practicing these questions will help you reinforce your understanding of key concepts and prepare effectively for the CCNA exam. Simulations are an essential part of exam preparation, providing hands-on experience with network configurations. Lab 1. Configuring a basic switch. Objective: configure a Cisco switch with basic settings, including hostname, passwords, and IP address. Steps: enter Global Configuration Mode. Set the hostname using the hostname command. Configure passwords for console and VTY access. Assign an IP address to the management interface. Lab 2. Setting up a static route. Objective: configure static routing on a router to enable communication between different networks. Steps: enter Global Configuration Mode. Use the IP route command to define the static route. Verify the route using the show IP route command. Lab 3. Configuring a DHCP server. Objective: set up a DHCP server on a router to provide dynamic IP address allocation. Steps: define a DHCP pool using the IP DHCP pool command. Specify the network and default gateway. Exclude addresses from the pool using the IP excluded address command. Lab 4. Implementing NAT on a router. Objective: configure NAT to translate private IP addresses to a public IP address. Steps: define the inside and outside interfaces using the IPNAT inside and IPNAT outside commands. Create a NAT pool with public IP addresses. Configure NAT rules using the IPNAT inside source command. Lab 5. Creating and assigning VLANs. Objective: configure VLANs on a switch and assign ports to VLANs. Steps: create VLANs using the VLAN command. Assign ports to VLANs using the switchport access VLAN command. Verify VLAN configuration with the show VLAN command. Lab 6. Setting up a basic firewall. Objective: configure a basic firewall on a router to control incoming and outgoing traffic. Steps: define access control lists, ACLs, to specify allowed and denied traffic. Apply ACLs to the appropriate interfaces using the IP access group command. Lab 7. Configuring OSPF in a small network. Objective: set up OSPF routing in a small network to enable dynamic routing. Steps: enter Global Configuration Mode. Enable OSPF using the router OSPF command. Define OSPF areas and assign interfaces to areas. Lab 8. Implementing IPv6 addressing. Objective: configure IPv6 addresses on network devices. Steps: enable IPv6 routing using the IPv6 unicast routing command. Assign IPv6 addresses to interfaces. Verify IPv6 configuration with the show IPv6 interface command. Lab 9. Setting up SNMP for monitoring. Objective: configure SNMP on network devices for monitoring and management. Steps: Define SNMP community strings using the SNMP server community command. Configure SNMP traps and notifications. Lab 10. Configuring a site-to-site VPN. Objective. Set up a site-to-site VPN between two routers to enable secure communication. Steps. Configure IPsec settings, including encryption and authentication. Define the VPN tunnel using the cryptomap command. Apply the VPN configuration to the appropriate interfaces. Practicing these simulations will provide hands-on experience and prepare you for the practical aspects of the CCNA exam. A review checklist helps ensure that you have covered all the essential topics for the CCNA exam. Network fundamentals. Review the OSI and TCP, IP models, IP addressing, and network devices. Ensure you understand the basic concepts and functions of each layer and device. LAN switching. Study VLANs, trunking, and Ether channel. Understand how to configure and manage switches, create and assign VLANs, and implement link aggregation. Routing technologies. Focus on routing protocols such as RIP, OSPF, and EIGRP. Review static and dynamic routing, routing tables, and route summarization. WAN technologies. Learn about PPP, frame relay, and MPLS. Understand the configuration and troubleshooting of WAN connections and protocols. Infrastructure services. Review DHCP, NAT, and NTP. Ensure you can configure and manage these services on network devices. Security fundamentals. Study ACLs, VPNs, and firewalls. Understand how to implement security measures to protect the network and control traffic. IPv6. Review IPv6 addressing, configuration, and routing. Understand the transition mechanisms and differences between IPv4 and IPv6. Network management. Focus on SNMP, Syslog, and network automation. Learn how to monitor and manage network devices effectively. Wireless networking. Study wireless standards, security, and configurations. Understand how to set up and secure wireless networks. Exam preparation. Practice with questions and simulations, review key concepts, and ensure you are comfortable with the exam format. Focus on time management and ensure you get enough rest before the exam. Use this checklist to guide your final review and ensure that you are well prepared for the CCNA exam. Final thoughts on preparing for the CCNA exam. Stay confident and focused throughout your preparation. Believe in your ability to succeed and stay motivated. Utilize study groups and forums for support. Engaging with peers and discussing topics can provide new insights and reinforce learning. Revisit official study materials regularly. Cisco Press books and official guides are reliable sources of information that can help clarify complex topics. Continue hands-on labs to reinforce your understanding of practical configurations and troubleshooting. Keep up with networking trends and updates. The field of networking is constantly evolving, and staying informed will benefit you in the long run. Ensure proper rest and nutrition. Taking care of your health is crucial for optimal performance during your study sessions and on exam day. Maintain a positive and persistent mindset. Challenges are part of the learning process, and persistence will help you overcome them. Arrive early on exam day to avoid any last-minute stress. Ensure you have all necessary identification and materials. Consider advanced certifications after completing the CCNA. Continuing your education will open up more opportunities and enhance your career prospects. Reach out for support and guidance when needed. Instructors, mentors, and peers can provide valuable assistance and encouragement. Good luck with your CCNA exam preparation. Stay dedicated, and you'll achieve your certification goals. In conclusion, preparing for the CCNA certification involves a comprehensive understanding of various networking concepts and hands-on practice. The certification benefits include global recognition, career opportunities, skill validation, and higher earning potential. The exam details such as the exam code, duration, question types, passing score, and registration process are essential to know. The domains covered include network fundamentals, LAN switching, routing, WAN technologies, infrastructure services, security, IPv6, network management, and wireless networking. Study resources such as official guides, online courses, practice exams, video tutorials, study groups, labs, forums, flashcards, Webinars and simulations are invaluable for effective preparation. Review key concepts like the OSI and TCP, IP models, network devices, IP addressing, subnetting, Ethernet basics, switching concepts, STP, Etherchannel, LAN design, routing basics, routing protocols, inter-VLAN routing, route summarization, ACLs, DHCP, NAT, NTP, SNMP, QoS, 1 concepts, PPP, frame relay, MPLS, VPN, security fundamentals, firewall basics, VPN security, wireless security, AAA, network management, Syslog, CDP, network automation, cloud services, IPv6 basics, IPv6 address types, IPv6 configuration, transition mechanisms, and IPv6 routing protocols. Use practice questions and simulations to test your knowledge and gain hands-on experience. The review checklist and final thoughts will help ensure you are well prepared and confident for the exam. Stay focused, use the resources available, and approach the exam with confidence. Good luck on your journey to becoming CCNA certified.